mention, so of course the homework is due, the homework's due now, so if you haven't turned it in already, make sure you do so. One of the problems I got from the homework was section 1.4, problem number 108, which I have displayed here on the screen. So I had a few questions about this one, and really there's only one step you have to do, which is the step that I have following the statement of the problem. So you just simply divide both sides by secant of 2 theta plus 6, and then from there it follows example 6 from the notes exactly. So that's all you have to do for that one. So I wanted to give everyone an idea for that problem so trig functions can be moved around as such if they are multiplying one another. So that's pretty much it for this one. Besides for that, I'm going to continue lecturing where we left off in section, I believe, 2.2. But before I do that, I want to give everyone an update that next week, Monday and Tuesday, will be when the Unit 1 assessment will be. This is something, I'll talk more about it on Thursday. Thursday, I will have a review session for it. But I just wanted to give you a heads up that it is that first assessment. You can treat it as a test. That's going to be either Monday or Tuesday, depending on when you want to take it. But you can take it whenever you want. You don't take it in class. You take it on your own. You take it through Moodle. And again, I'll explain it more on Thursday. But just to give you an idea that is sort of the generic structure of it and to make you aware of it. So besides for that, let's go ahead and start the homework. So do you have something to turn in for me?
Yeah.
All right. So go ahead and just as a refresher, we were talking about reference angles, which are very important in this class. This is probably the most important thing we talk about. This is the most important thing we talk about in this unit, because what they allow us to do is to take larger functions, larger values, and reduce them down to acute angles. So that way we can view them using triangles. That's the point of all of this. We can take large values, reduce them down to small values, so we can form acute triangles out of them. And from there, our perceptions of our spatial interpretations of opposite, adjacent, and hypotenuse follow. I know someone in the last class asked about quadrantals. Is it you? Maybe. Whatever the case may be, quadrantals was mentioned before by somebody. That was you? Okay, cool. So we have a quadrantal problem coming up. But so we're going to go through all of these again, but we're going to add one thing, and that's the trig function itself. So we're kind of stepping it up. We're just going one step further with it, but we're doing pretty much the same stuff from before. So let's go ahead and start off with the first one, cosine of 135 degrees. And we start off the same exact way. So before, what we did was we asked, is the degree value a positive number that's less than 360? So remember what we did before. We took some of these values and we used that approximation symbol. So you may notice for number 3 here, we took 422 and we reduced it down to 62, or we took negative 175 and we reduced it to 185. That's because we like these angles to be, well, we want them to be positive and less than 360. They're a lot easier to work with that way. They're a lot easier to throw on a graph. And before, I said approximated because they are not the same angle, but we can pretty much interchange them and the problem will work out the same way. In this section of problems, since there is now a trig function involved, we can now say equal. It won't apply to number 1, but as as a method of foreshadowing, we will do this for problem 2. You might want to think about that one. So problem 1, we don't have to worry about it because 135 degrees is in the interval we want. It's positive and less than 360, so we don't have to mess with it. So let's figure out where this belongs on an XY plane. Actually, I might need some more room here, so. One more time. There we go. So 135 degrees. So here would be 90. And the next step would be 180. So we're going to go about here. Doesn't matter. So something like that. So we get 135 degrees from that. And so naturally, we like to triangulate, as we did before. And the reference angle is the angle of the interior. It's the measure of the interior angle, depending on which quadrant we're in. So I'm going to use this in blue. So in blue here, that is the reference angle. In this case, it's just that additional portion that completes the measure to the straight line. It's the distance from the x-axis, the angular distance from the x-axis. And so by having a visual representation, it allows us to see how to construct or how to, what arithmetic we have to apply to figure out the reference angle. So I normally use a theta with an apostrophe next to it. That means that's the reference angle notation. And in this case, it seems to be that it's 180 degrees minus 135 degrees. 180 would be the flat line itself, and 135 degrees would take away everything before to give us that portion that's left over. So it seems to be 45 degrees. So that is the reference angle. Is that good so far? So that's the stuff from before. So it's treated the same exact way as before. Now, the modification here, we can go ahead. So I'm going to rewrite the triangle down here. So it's the same triangle, just down here. And we know that this is 45 degrees. But since it's 45 degrees, we know that this is a special triangle. It's a 45-45 special triangle. And if you recall from before, the special triangle, it tells us that the two sides are both 1 and the hypotenuse is the square root of 2. So we know the values to fill in. So for 45-45, we know it's 1, 1, and square root of 2, with one exception. Does anyone happen to see the exception? I mean, what I have is right. Say that again?
Negative.
For which one?
The X and the Y.
So here, notice I'm going to put a negative in front of that one alone. Because in quadrant 2, we have to go to the left, which is a negative distance, but going up is positive. So going to the left is negative, so hopefully everyone can see our virtual as well. Going to the left is negative, and going up is positive. So that's why we have -1, or the horizontal one being negative, and then the vertical one is positive. And the hypotenuse is always positive. But once you have that figured out, then finding cosine of that value is the final step. So this was the original problem. Cosine of 135 degrees is now reduced to just determining cosine on this right triangle that I have now constructed. So cosine is adjacent over hypotenuse. And that is now -1 divided by the square root of 2. So adjacent is the -1 and the hypotenuse is square root of 2. And that would be the final answer. The -1 over the square root of 2. Or if you like to rationalize the denominator, it's negative square root of 2 over 2. Same thing. But you don't have to rationalize the denominator, just if you want to. Which, in my summer class, some people did, so you can do whatever you want. So that is the extension to reference angles. We're going to do a few more naturally, but does anyone have any questions, initial questions for number 1 here? Virtual people? Okay. All right, so next one is cosecant of -120. So as I mentioned before, I would rather not look at -120, but instead look at a positive coterminal angle like we did before. So instead of -120, we can look at, as I mentioned, something coterminal, which means some multiple of 360. What's that?
240.
Yeah, 240. So just -120 plus 360. And now the angle is positive and it is less than 360. So that's a much easier angle to use. And I can now confidently put an equal sign and not an approximation sign because the trig functions are equal. The angles themselves are not equal, but the trig functions will be equal. So that's why I'm putting an equal sign instead of an approximation symbol, because these will be equal. But now that we have that, let's do what we did before. So 240 degrees, that's 90, that's 180, doesn't quite reach 270. So it'll come out to about right here, which we can proceed to triangulate. So it taps out in quadrant 3. So what is the reference angle here in quadrant 3? It's going to be an overlap of some of the angle we already had, because it's the distance to the closest part of the x-axis. So it's that part in blue that I have. So with this visualization, we see which arithmetic step we have to take. It's the whole angle, 240, minus where the flat line is at, 180. That gives us 60. So that angle is 60 degrees. It's 180 for the flat line plus the additional 60 to give us the 240 in total. So now what I'm going to do, like I did before, is redraw the triangle. If you have enough space on yours, you don't have to redraw the triangle. I just need more space here. Okay, so here is the triangle, and here is the 60 degrees. So naturally, this is a 30-60 triangle, which means we know that these segments, you might already know them, but I'll go and reference them just in case. 30-60 right triangle have segments of square root of 3 for 60, 1 for 30, and 2 is the hypotenuse. So it's 1 square root of 3 and 2. And you do have to memorize which one is which. We'll do it down here. So for 60 degrees, it's going to be square root of 3. And for 30 degrees, which is assumed to be this one over here, it's 1. And the hypotenuse is always, that one's not going to be too ambiguous. And it makes sense that the larger angle gets the larger value. So 60, of course, gets square root of 3, which is larger than 1. Bigger angle, bigger segment. And now we have to address the signs, because there's going to be some negative signs here. So you want to try the signs again?
This is, yeah, I got it mixed up. This is negative for the opposite and adjacent.
Yes.
Isn't it supposed to be 2, not square root of 2?
Sorry, yeah, you're right. You're definitely right. Yeah, sorry about that. Definitely 2, yeah. So for those of you virtual as well, yeah, you're definitely right. Thank you. But, and you're also right, as in they should both be negative. They should both be negative because you're going not only to the left, which is a negative distance, but you're going down, which is negative as well. So they're both negative. So in quadrant 3, both opposite and adjacent are negative values. So make sure you have all those corrections, or that correction and what I've just added in terms of the negative signs. And so from here, now that we have the right triangle, then we're just looking for cosecant. And the triangle helps us find that really quickly. So cosecant, well, let's see, that's 1 over sine. Sine is opposite over hypotenuse, so this is going to be hypotenuse over opposite. Hypotenuse over opposite. So let me make sure I did that right. 1 over sine. Sine is opposite over hypotenuse, so then we switch that. So it's hypotenuse over opposite. Hypotenuse is 2, and the opposite of 60 is negative square root of 3. Okay, cool. So that would be your answer. So notice it's 1 step further from reference angles, and it shows how reference angles can be used to take some large value, simplify it down, and then we can use special triangles to help fill in this and get us a nice answer. How does everyone feel so far? So if those are okay, the next 2 should probably not be too bad. Yeah, and I'm just now seeing square root of 2, yeah. So hopefully that correction helps. Okay, so let's move on to tangent of negative 270, which I am going to rewrite using coterminal angles. So not negative 270, but it should be 90, right? Okay, cool. So you just add 360 to the angle. Because we want it to be positive, it just works out a little bit nicer. Now, Blake, this is where your question from before comes into play. Because now we want to plot 90 degrees, but naturally, that puts us right here on the axis. So that means triangulation is out the window. It's gone. So you might think, well, what do we do now? This is where you have to pick a point and use those X, Y, and R formulas. So there's no reference angle. There's no reference angle. We cannot find a reference angle because there's no distance from the x-axis that we can measure. So instead, so quadrantals have their own method where you pick a point, some point that makes sense. So here we could pick 0, 1. Now something that would make sense to be on the positive y-axis. We can go ahead and figure out the radius as well, or r, the value r. So 0 squared plus 1 squared, which you might have already determined, that's 1. So we have x, y, and r, which means now we can figure out, well, tangent of 90. And the formula for this one, it's y divided by x. So we didn't even need r, but we have it anyway. So that's 1 divided by 0. That's interesting. You get 1 divided by 0. That doesn't look right. So is it undefined? Now what does the calculator say? Tangent of 90 degrees. Yep, it's undefined. So that's it. That's how you conclude. It's undefined. You cannot find the tangent of 90 degrees. It's just undefined. So that's all you do for 3. And that's the general process for any quadrantal. How does that one sound? Is that okay? Okay, let's do problem 4 as well. So we have sine of 405 degrees, but I don't really like 405 degrees. That's a little bit too large. Too large. We can reduce it and get a much simpler problem. Instead, I'd rather work with sine of 45. Isn't that it? Sine of 45 degrees. Yeah. Because I am finding a coterminal angle that is smaller. 4 or 5 wraps around too many times. So I'd rather it just not wrap around so many times. So I'm subtracting 360 from 405 to get rid of all of those additional tedious loops. And when you subtract 360 from it, you just get 45. So we can go ahead and determine this one. Now 45 degrees, it's right smack in the middle of the first quadrant. And what's good about being in the first quadrant, your angle is your reference angle. So there's none of this tedious having to subtract one thing from another or add one thing. It's just you get the reference angle in quadrant 1. So from here, it's just, well, the segments of a 45-45 triangle, which if you recall, they were 1, 1, and the square root of 2. And we don't have to have any negatives. It's all positive. It's right and up. So it's just a matter of finding 45 degrees, or sine of 45 degrees, which is opposite over hypotenuse. Or if you like to work it out even further, you can do so. But this answer is perfectly sufficient. So this is the general process for finding reference angles, and even more so, how to solve trigonometric functions, or find the values for trigonometric functions of angles that are really just oblique in a sense. Does anyone have any questions before we move on to the last problem of the section? Okay, well, we'll move on, like I said, to the last problem of the section. I'll keep it right there for those of you who might still be writing. So example 4 here is definitely a little bit different, as they do not give us an angle. They instead give us the value and ask us to find the angle, or possibly angles. So we're working backwards in essence. We are working completely backwards. So this is a pretty important problem here. So apparently this alone will help us find values for a bunch of angles. And so the first thing I want to think about is we actually had a problem kind of similar to this before, I remember. Where was it? Oh, we did. I think example 7 might be the closest that I can think of, but in any case, it might or might not jog your memory. But we want to find the quadrant or quadrants for which such an expression is even possible. I mean, if anything, they're asking us to find a bunch of values in this interval. And so they give us that secant is a negative value. Now, secant is secant's not negative everywhere. Secant is only negative in certain quadrants. What we did for that problem I'm thinking of is we instead wanted to know which quadrant is cosine of theta equal to negative 1 over the square root of 2 possible. And you might think, where did I pull that from? Well, with the signs of the trig functions, it's all students take calculus, which is an acronym for, well, the leading letters are an acronym for all the trig functions are positive, sine is positive, tangent's positive, cosine's positive. So naturally, we want a sine, cosine, or tangent. I just so happen to go with cosine because that's which trig function's associated with secant. So which quadrant or quadrants is this possible in? Well, where's cosine negative? Yeah, it can't be 1 because everything's positive there. Quadrant 2 is just sine, so that one works. And then quadrant 3, let's see, T for tangent, so quadrant 3, and then 4 is cosine, which is positive. So it can't be 4, so it has to be 2 and 3. So what I'm going to do with this information is I'm going to assume, let's just look at quadrant 2. Let's find the quadrant 2 one, and then we'll move on to the quadrant 3 one. So some angle in quadrant 2, we don't know what it is. It's going to be here somewhere. So this might not be built to scale, but we're just drawing any angle in quadrant 2. Naturally, we can triangulate if we did have an angle. And so if only we knew what the sides of that triangle were. Wait a minute. We do. We do know what the sides of that triangle are. Cosine is adjacent over hypotenuse. So if anything, if we had a reference angle, then what would be adjacent of that would be, I'm just going to put the numbers for now, and not negative sign we'll worry about in a bit. Adjacent would be 1. The hypotenuse would be the square root of 2. Now, of course, that negative's got to go to one of those, and it cannot ever be the hypotenuse. So we'd have to go to this one, which makes sense because it goes to the left. But then you might notice that these segments are very familiar. These values come from a 45-45 angle. And in fact, if you were to use the Pythagorean theorem, you would determine that this last value is 1. But in other words, knowing the segments of the triangle helps you find the reference angle. Before, we were using the reference angle to help fill in the segments of the triangle, but now it's the reverse direction. So the reference angle is equal to 45 degrees because the segments are the segments that correlate with a 45-45 triangle. Now that we know the reference angle, and we know that both angles have to lie in, that we're going to have two answers, one in quadrant 2 and one in quadrant 3, then all we have to do is figure out how do we apply the reference angle to get a final angle in quadrants 2 and 3. Well, we'll start off with quadrant 2. So quadrant 2, we know that the reference angle is 45. So if we work backwards and we know that the reference angle is 45, then the whole angle itself, which I'm highlighting in red, would have to be 180 minus 45. Which is 135. And that's one of the answers. And for quadrant 3, so an angle in quadrant 3 would jet out like this. The reference angle is 45 degrees. So the question is, what would the whole angle be?
225.
Yeah, 225. So that would be the 180, which would be the flat line. And then it tells you, just go 45 more degrees. And then that's where you get the 225. So that's your two answers. So you get two answers for this problem. It's okay that you get two. You get 135 for the quadrant 2 answer, and you get 225 for the quadrant 3 answer. And that would conclude this section. So, does anyone have any questions about anything from this section before we move on? If not, as I mentioned, the next homework is due Friday. If you want to turn it in person, Thursday will be your chance to do so. Or Friday, if you can get in the building and slip it under my office door. In any case, however you get it to me, as long as I have it in some manner by Friday at midnight, that's fine by me. And so the homework sections, I sent out an email, I believe yesterday, and I just reemphasized everything that's due and all that stuff. So the homework assignment in general. And you can all email me. I only got one email about the homework, and then it turns out a lot of people struggled with 108. I got one email, actually 2 emails, I'm sorry. I got 2 emails about the homework. So Trig's my favorite class to teach. I don't mind answering trig questions. I don't like answering my college algebra questions for those students. Those get a little annoying. Trig is fun. I do not mind answering trig questions. They're a lot more interesting. So just to give you all some insight, I don't mind. And for those of you who had me for college algebra last semester, sorry, but it's a lot more interesting. All right, let's move on to 2.3. And before I get started, so I have 2 more sections to teach. I'm going to be able to wrap them up quickly. 2.3, this is a calculator section. It's a 100% calculator section. So since we're getting close to test time, I did change the number of problems that are assigned with this homework section. I don't want this to be some hassle, so I'm getting rid of a good chunk of these. 16 and 19, they're just gone. 25, gone. 27 and 28 are gone. So just 29. And then 33, 34. So instead of 15 problems, it's 1, 2, 3, 4, 6, 7, 8, 9, 10. There, so 5 less problems. And this is a calculator section, so you should be able to get through these pretty quickly. A bunch of them are one-liners. So again, since the test is coming up, I don't want this to be a hassle of a homework section. I'll probably have this one due Tuesday. Or I might even have it optional. I'll ask about that on Thursday. But as I mentioned, I think the section's very straightforward. It is helpful. It's basically, well, how do I do all this in the calculator? So it even says, you can use a calculator. So a lot of these should be pretty quick to knock out. If it's not just you write the answer, then it might be one line and then you write the answer. So provided you know how to put the DMS stuff in the calculator, if not, you need to go refresh yourself on how to do that, then what you should get, and to make sure that your calculator is in the correct format before the test happens, because if you switched it to radians, then you're going to get everything wrong. I get 3791. So this is initially to just make sure you can put these in the calculator correctly. Did anyone else get something different? Or did you get that? Because in my notes, I'm off by a 10,000th of a decimal place. I probably did it wrong, but.
What'd you have on?
In my notes here, I have 3789.
I got 37 on one.
I mean, I'm okay. Okay, then I'll just ignore what I did there. I don't know. Okay, it's right here. It's definitely right here. Okay, cool. So you might be wondering, okay, well, that one was pretty easy. I mean, I pressed sign and then I put all that in the calculator. So again, you need to know how to do the DMS stuff so you can knock these out really quickly. But what about for part 2? So I'm looking at my calculator. I have this one, and I don't see a cotangent button anywhere. So what you have to do is realize that cotangent is 1 over tangent. So like I said, if anything, these are one-liners. Remember, cotangent is 1 over tangent, and then you could put this whole expression in the calculator. And if you did that correctly, you should get 2.4813. So make sure you get that answer. Is that what everyone else in here is getting? If not, check and make sure you put it in correctly. So part 3, same idea. Secant of 24, I don't see secant in the calculator. All I see is sine, cosine, and tangent. So the one-liner would be 1 over cosine of 24 degrees. And then you could put this whole expression in the calculator. So that's it. For problem 4, this one might look weird because there is one of the less familiar trig identities already in the denominator of a fraction. So how do you think we can kind of fix this one?
It's the reciprocal identity of sine, so you just flip it over and be sine 28 over 1 or sine 28 degrees.
Yeah, it's just sine of 28 degrees. It's pretty much going in reverse of steps 2 and 3. It's going in reverse. It just so happens that the thing that we're trying to get to fixes, so it reciprocates again, in other words. So cosecant is 1 over sine, but 1 over sine, pretty much the reciprocals cancel. You end up reciprocating twice, and that cancels each other out. And then you could just throw this in the calculator. What did I put? I thought. Okay, so good. Just how to put it in the calculator. So if you did not get those answers, please make sure you can. But yeah, that's pretty much it for that first collection of problems. And we also move on to something that's a bit more important about the inverse trig functions. So before, we were using the calculator to figure out the values. But now what happens if we're trying to figure out the inverse values? So inverse, the notation is up here. So you might notice the -1 exponent, which does mean inverse. The 3 main ones that we will try to obtain are sine inverse, cosine inverse, and tangent inverse. And this is a way to determine what really this sort of gives us the reference angle. There are the calculator doesn't do it perfectly, as in it might interpret it a different way. It may give you something very close to the reference angle. But that's ultimately what it's doing here. And so for problem 1 here, we're trying to figure out, we don't know what the angle is, but we know what the value is. And so really the algebra behind this is we're applying sine inverse to both sides. You don't have to write this down. I'm just explaining where this is coming from. And really what's happening, so you're applying sine inverse on both sides, and on the left side, sine inverse and sine cancel. So that's why you would get theta is equal to sine inverse of 0.4271. So in other words, this is you moving sine to the other side. Such as in algebra, if you had x plus 3 is equal to 4, then you would subtract 3 on both sides. Down here, it's how do you move sine to the other side? Well, you make it inverse. Plus and minuses are inverse, sine and sine inverse are naturally inverses. So you might notice in your calculator, above sine, cosine, and tangent, you have sine inverse, cosine inverse, and tangent inverse, right above the trig functions. And so you would simply press, at least on this calculator, second in sine inverse, so you should see sine inverse of 0.4271. And if we all did it the correct way, and correct me if I'm wrong, it says 2 decimal places, 25.28 degrees. And the output of an inverse is an angle measure, because we're solving for theta, which is an angle. So hopefully everybody got the same thing, because if so, the next few should be pretty straightforward. Problem 2, well, the problem with problem 2 is that secant inverse is not in the calculator. Moving secant to the other side isn't so easy. So instead, what we have to do is flip both sides, reciprocate both sides, actually like we did on the last problem of the previous section. So if you flip secant, then you get cosine. And by flip, I just mean put it under 1, or if you had a fraction, you would flip it. And so you would flip the other side as well to get exactly this. So you are perfectly allowed to do this at any point if you have an equation or something like that. As long as you reciprocate one side and you do the same thing to the other side, that is an appropriate algebraic operation. But the only reason I did that is we could take cosine inverse and get the angle by itself. So we're moving cosine to the other side to get the variable theta by itself. And now this is something you can put in the calculator because we have a cosine inverse button. And I get 78.18 degrees. If those two work out pretty okay so far, then again, the next two probably won't be too bad. For number 3, we can just apply the inverse directly because we have tan inverse on the calculator. So we move tan to the other side by making it an inverse. And we have tan inverse on the calculator. So tan inverse of 3.8125. So that one's pretty easy. 75.30 degrees. Again, the output of an inverse function is a degree. So that's all it is for that one. Problem 4 is pretty similar to problem 2. The issue arises that cosecant does not have an inverse button on the calculator, so we want to rewrite it as a trig function that is on the calculator. Naturally, cosecant, if you reciprocate cosecant, it's just sine. So you could flip cosecant to make it sine, and equivalently, you can flip the other side to make it 1 over that initial value. And you apply the inverse function the same way. What'd you get?
Undefined.
What'd you get?
Same.
Is that an error? Well, I mean, of course it's an error, but is that, were we
Yeah.
supposed to get that? So the answer is in fact undefined. And to tie this in to what we've talked about before, I'm just curious what that fraction is. 1 divided by 0.1254. It's about 7.97 blah, blah, blah. It says sine of theta is equal to pretty much 8. Sine cannot output numbers greater than 1. Remember that? That's why. So the arithmetic there was right, and we should have run into this undefined thing, as we did. So this is a further confirmation that, well, sine cannot output numbers greater than 1 or less than -1. And this is one way how you can run into that with the calculator to verify this. So we had these range problems earlier, and maybe the last class period or the one before. You could use the calculator to verify those, because it's not really much work to show other than I know the definition or the calculator told me so. So that is that for that section. Does anyone have any questions before we move on to the final section? So I didn't imagine this was going to cause too many people issues. It's just a calculator section with a little nuance of how to use the reciprocal identities. Let's move on to section 2.4, which is the last section that's pertaining to the Unit 1 assessment that we'll have next week. And it's going to recycle a lot of ideas we've already talked about. Naturally, I wanted to not make this section as rigorous, so I took out number 31. So 31's just gone. And I think, I'm trying to remember. I don't have it here, but I have an issue with another one. Oh, that's not it. No. 7. No, I have to have those. Okay, never mind. That's where it says. Okay, so 5 problems. And there's pretty much 1 problem per example that we will talk about. If we don't finish an example, we just won't talk about that corresponding thing. All right, so to solve a triangle, if it says solve a triangle, just simply means find every side and every angle. So that leads directly into example 1, which gives us really 2 angles and 1 side, and we're going to figure out all the remaining angles and sides. If anything, one of these values we can figure out really quickly. Anyone want to at least say one of these that we can figure out really quickly?
Angle B.
We can figure out angle B really quickly. We can figure out this angle really quickly. Oh, really quickly, I mean, we can figure it out pretty easily, I think. So angle B, we know the other two angles. And we know that all angles in the triangle add to be 180. So that's why for angle B, 180 minus 90, because we have a right angle, minus the 31 degrees, 40 minutes. And really, that's just calculator work. 180 minus 90, which is, of course, just 90. 31 degrees, 40 minutes. And in fact, if you type in the 180 and the 90 without the degree symbol, but then the 31 degrees, 40 minutes with the appropriate notations, calculator understands that there's an understood degree associated with the 180 and the 90. So you can type it in symbolically exactly as I have it written down right now, and the calculator will interpret it the correct way. If you're rushing through and you forget and don't forget. But you should get something that looks like 58.33 blah, blah, blah. Naturally though, if an angle is given as DMS, then really you want to be consistent and give your final answer as DMS. So remember, you have to convert this. And there's just one button in the calculator. That will give you the conversion. Some problems will ask you to put it in DMS. And on a test, if you ignore that, it'll probably be like the slightest deduction imaginable. But that would be at least the angle. So again, being familiar with the DMS stuff will save you some time. How do you convert it? I'll answer that after class so I can show you up close. But hopefully you have one of these calculators. Or if someone wants to tell her how to do it in the chat. I want to make sure I cover everything. I'll gladly talk about it afterwards. So if anything, we have angle B. So cool, we have angle B. It's 58 degrees, 20 minutes. Now we have to figure out the two missing segments, C and B. So we cannot, if you think, can we use the Pythagorean theorem? Generally, I don't use that. And I try to just use the trig identity, or not the trig identity, it's just trigonometric functions. So let's just pick one of these to solve for. It really doesn't matter. Here, B or C? B, sure. Solve for B first. How can we figure out B? It's a good question. Well, we are given all the angles in one side. So we're going to utilize that one side to our advantage. So we can really pick any angle as well. Blake, pick an angle, A or B. We can pick angle A, sure. So with angle A, that gives us an idea of opposite and adjacent. And, well, the hypotenuse as well. So if only there was a trig function relative to that angle that would incorporate all the information we know and only leave one variable. This might be tricky, so if you don't know it offhand, that's okay. But if 31 degrees and 40 minutes is our angle, which trig function would incorporate the known value that is adjacent, the unknown value, unknown, let me say that again, incorporates the segment which is known that is opposite, as well as the unknown which is adjacent. That's tangent. That is tangent. So in other words, tangent of 31 degrees and 40 minutes So what is opposite of that? That's the 35.9. What is the, and so what is that over? That's over adjacent, which is B. So look at that. We just set up an algebra problem. So we picked tangent because tangent allowed us to grab one known value and one unknown value. If we would have picked, say, sine, well, sine would have excluded B entirely. If we would have picked cosine, we would have picked B and C. So that's two variables. That's not good. Definitely don't want to deal with Calc 3. So now we have to solve for B here in this problem. So B will end up being, I'm going to skip a little bit of algebra because you would multiply both sides by B to clear the denominator, and then you would divide by the tangent to get B by itself. But then you would get exactly this. And good thing we know how to put trig functions in the calculator. If you did all that correctly, then you would get 58 point, and so 2 decimal places, 0.20. This is not an angle. This is just a segment value. So this would be kilometers. This is a segment we found. This is not an angle. Finally, let's go ahead and find the other missing segment, which, again, you could now use the Pythagorean theorem. I'm going to not use it that way so we can practice with the trig values themselves. So we found B. Now we need to find C. And since we know the other two sides, we have a lot more options of opposite, adjacent, and hypotenuse to utilize here. So for C, let's stick with A as our angle. We can actually, so we can actually pick, let's see, to solve for the hypotenuse, really we can choose sine or cosine. Both of those incorporate a hypotenuse. I'm just going to pick sine. So sine of 31 degrees and 40 minutes is equal to opposite, which is 35.9, divided by the hypotenuse, which is unknown. Naturally, we can solve for C using some simple algebra. If you did all of that correctly, you should get 68.38. And now we have solved for every angle and every side. We're going to do, next few are going to be similar. Does anyone have any questions before I move on for now? If not, let's move on to example 2. So here they just tell us what these segments are, and I would suggest you construct a triangle. And maybe that might not be the best one. Okay, so we'll go ahead and construct the triangle ourselves. There's an A and there's a B, and they tell us that C is the 90-degree portion. So if anything, C is okay where it's at. Little a needs to be across from big A, or needs to be opposite of big A. So 18.9, that's why I'm putting it there specifically. Little c needs to be across from C, so that's why I would put 46.3 here. And this is all they give us. So we have to solve for the missing side and the two angles. Well, it's going to be hard to solve for the missing side without an angle to work with. I mean, sine of what? Cosine of what? We don't have any of the angles. So it makes sense to look for an angle first. Which angle should we look for first? It doesn't really matter. Let's look for A. All right, so we want to find angle A, and we want to somehow utilize the two bits of known information, the 18.9 and the 46.3. So how does angle A relate to the 18.9 and 46.3?
Sine.
We can use sine. So sine of A, well, what's opposite of A? Opposite of A is 18.9. And what's the hypotenuse? It's 46.3. So hey, that works out perfectly. But how do we solve for A? The sine's in the way. Oh, wait a minute. We learned how to do this in the calculator. We can move the sine over. So that's when we can do sine inverse of that opposite over hypotenuse thing. And I get 24.09. Which I must convert to degrees, minutes, and seconds. It does say just give it in degrees and minutes. It doesn't say anything about seconds, so I just leave off seconds. I guess technically you could round up, but that goes into metrizable spacing that I don't feel like getting into. This is perfectly fine. Again, if it asks for degrees, minutes, seconds, and you give me decimal degrees like the step before, I don't know. It'll be, I don't even know what I'll do. Probably nothing. Now that I think about it, I'll probably just look at it and think, that's not a big deal. I don't even know. I'll figure it out. But that's angle A. And so the question is, well, how do we figure out angle B? Well, guess what? We don't have to do that same process because we know two of the three angles. We can just subtract. So for angle B, just 180 minus 90 minus 24 degrees in 5 minutes. It's 65 degrees and 55 minutes. We could just subtract. I'm trying to think about, there's still the case of the missing side. Still the case of the missing side. And I have no room up here. So there's little b that we still yet to find. I'm just going to put the work down here. To figure out the missing side, because we have to solve the triangle, we have to figure out, well, we can either use the Pythagorean theorem, which I tend not to use, or some collection of the angles to, or one of the angles to help us determine that. So it turns out that tangent of A is equal to 18.9 over B. But we know that A is 24 degrees and 5 minutes. That would be B. I'm going to skip example 3, and what I'm going to do is make example 3 the replacement problem for 47. So 47's gone, it's 46. In 46, they give you a nice diagram, so it's much easier. It's much easier than 47, I promise. So 46, I'm assigning that one for the homework. And that is example 3. Tomorrow I will have to quickly explain the angle of elevation. And it's just one problem here that I can get over and I can talk about in 5 minutes. But yeah, I'm pretty much out of time. As I mentioned, I replaced 47 with 46, which is the missing example here. They have a diagram for you in the book, so it should be pretty easy to piece together. And it will fall under one of these examples that I did. I'll talk about the angle of elevation tomorrow or the next day in class, and remember all the due dates. I think that's pretty much all I have for now. Does anyone have any questions in class, people? If not, you're free to head on out. Online people, if you don't have any questions, you're free to head out.